Hello students, today we will be solving question number 20. So in this question number 20, it has been said that a jar contains 175 ml of water and 70 ml of alcohol. Gopal takes out 10% of the mixture and substitute it by water of the same amount. The process is repeated once again. In that case, we need to now find out the percentage of water in the mixture. Okay, the options are 35.2, 30.3, 20.5 and 25.4. Okay, so what we'll have to do, this is water and this is alcohol. Okay, so we initially had 175 ml of water and 700 ml of alcohol. Now 10% will be taken out from 10% is taken out from the mixture. So basically 10% of water and 10% of the alcohol is also taken out. So minus 17.5, which is 10% of 175, minus 70, which is 10% of 700. So this gives us the value 157.5 and here 630. Now what happens? The amount which has been taken out, basically 17.5 plus 70, which is 87.5, that amount of water is now added up to the mixture. So plus 87.5. So the mixture that we now get is 245 ml of water and 630 ml of alcohol. So this is the mixture. This process is repeated again. So 10% is taken out, so 24.5 and 63 is taken out from here, and we are left with, let me write it up here. So this is water and this is alcohol. Okay, so we are left with 220.5 ml of water and 567 ml of alcohol. And now, so total of 87.5 ml was taken out. That 87.5 ml of water is now added up. So plus 87.5. So now we have 308 ml of water and 567 ml of alcohol, and the total amount stands up to 875 ml. So therefore percentage of water will be percentage of water will be equal to 308 by 875 into 100, which ultimately lands up to 35.2, which is given by option 1 over here. Let's go into the next question, which is question number 21. Now we'll be doing question number 21. So in question number 21, it has been said that the scores of amol and bemol in an examination are in the ratio of 11:40. Now after an appeal, their scores increase by the same amount, and their new scores are in the ratio of 47:56. Then the ratio of bemol's new score to that of his original score is, the options are 4:3, 3:2, 8:5 and 5:4. So these are the options that have been given. So it has been said that the original scores of amol and bemol in the examination are in the ratio of 11:50. So we can say let initial scores of amol and bemol be 11x and 14x respectively. Okay, and now it has been said that after an appeal their scores increase by the same amount. Let both of their scores be increased by, suppose, y. Okay, and in that case their new scores, the amol's new scores will be 11x plus y, and bemol's score would have been 14x plus y, and the ratio of these scores is equal to 47/56. And upon solving this structure, you will get that y is equal to 14 by 3x. So therefore the ratio of Bimal's new score to his original score, so therefore required ratio, so Bimal's new score would have been 14x plus y and his old score was 14x. So this comes down to 1 by y by 14x, and from this portion you can see that y by 14x is equal to actually 1 by 3. So this would have been 1 plus 1 by 3, which would have been 4 by 3, and which you could have written as 4:3, and this is nothing but the option 1. So the option 1 over here is the correct option. The next question is, which is question number 22. It has been said that let f of x be equal to maximum of 5x, 52 minus twice x squared, where x is any positive real number. Then the minimum possible value of fx is the minimum possible value of fx. So this is a fairly easy question. For that I'll try to incorporate a graph so that your understanding is very much clear. Let me insert a new page and start on with it. So for this, let us draw the graph. So if this is the x-axis and this is the y-axis, okay, so the line y equal to f5x would have looked somewhat like this. It would have been a straight line passing through the origin. So this is y equal to 5x, okay, and now we'll draw the line y equal to 52 minus twice x square. So for that I'll use a separate ink of a separate color. So let me do that. Okay, so let me take this color. So now 52 minus twice x square. So this would have been, if this is the y equal to 52, so it would have looked somewhat like this. Okay, 52. So the maximum portion of that graph now would have been, since we have been given that f of x is equal to maximum of 5x and 52 minus twice x square. Okay, so this is what we need to find out. So the maximum portion of that curve will be given by, let me use another ink over here, and since we have been given that x is a positive number, so we basically take that x is greater than 0. So we'll neglect this entire portion, will be neglected. So the only portion that we'll consider it will be this very part. Okay, as you can see in this portion, so as you can see from the graph, the function which is given by maximum of 5x and 52 minus twice x square will be minimum at the point at which they intersect. Okay, so if we find out the value of x for which 5x is equal to 52 minus twice x square, then we'll get the minimum value of the function f of x. So that is what we'll try to do now. Let me revert back to my original ink color. So let us do. So for that what we have to do is basically 5x will be equal to 52 minus twice x square. So this would have been equal to twice x square minus 5x or plus 5x minus 52 equal to 0. So 52 into 2, this would have been equal to, so that implies, so now if you get down to solving this problem, so this would have been equal to x into twice x plus 13 minus 4 into twice x plus 13 equal to 0. So this would have been twice x plus 13 into x minus 4. So this implies that x would have been equal to minus 13 by 2 or 4. But we have been already given that x is greater than 0. It is a positive number. So x equal to minus 13 by 2 is not considered, and therefore we have the value of x is equal to 4. and when the value of x is equal to 4, we get that f of x will be equal to, we can take either 5x or 52 minus twice x square. If we take 5x, then 5 into 4 will be 20, and if we take 52 minus twice x square, so 52 minus 2 into 4 square, so 52 minus 2 into 16, which would have been 52 minus 32, and we had to get 20. So the answer here is f of x is equal to 20. So this is the answer that we are looking for here. Now we'll be doing question number 23. So in this question number 23, it has been said that how many 2-digit numbers with a non-zero digit in the units place are there which are more than thrice the number formed by interchanging the position of the digits. So if we have a number of the format xy, then after interchanging this becomes yx, and it has been said that a number xy is thrice the number yx. So this gives us 10x plus y is 3 into 10y plus x, and this ultimately gives us that 7x is greater than 29y, and this gives us that x by y is greater than 29 by 7, which is approximately equal to 4.142, and so on. So now what will I do? It has been already said that in xy, which is the original 2-digit number that we have considered, the y is not equal to 0. It is a non-zero digit. So now if we take y is equal to 1, if y is equal to 1, then x has to be greater than 4.142. So in that case, x will be equal to 5, 6, 7, 8 and 9. So we therefore get 5 numbers over here, 5 numbers which satisfy the criteria that we are looking for. What happens if y is equal to 2? So if y is equal to 2, that implies that x can only then x has to be greater than at least 4.142 into 2, that is 8.284. So in that case, x has to be equal to 9. So we get one kind of number over here. What happens if we take x is equal to 3 and y is equal to 3? If y is equal to 3, in that case x has to be greater than 4 into 1.42 into 3, which would have been, suppose if we take 4, and so it is 13 point something or we can say 12 point something. X would have, but we have already mentioned that x is a digit. It is always lies in the range of 1 to 9. It is not more than that. So therefore y equal to 3 cannot be considered over here. So the total number of numbers which satisfy the criteria that we are looking for is equal to 5 plus 1, which is equal to 6, and 6, which is given by option number 4, is the correct option over here.